The science of heat, thermodynamics, and you. Thermodynamics is the study of how energy works. More specifically, it focuses on how heat, which is a form of energy, transforms and moves. It might sound complicated, but it's all around us. Think about how a warm cup of coffee cools down or how a pot of water boils on a stove. It governs everything from the smallest atom to the largest star. Thermodynamics plays a crucial role in our daily lives, though we may not always realize it. It's the driving force behind many technologies we rely on, such as power plants that generate electricity, refrigerators that preserve our food, and cars that transport us. Understanding the basic principles of thermodynamics allows us to design more efficient and sustainable systems. It helps us address global challenges like climate change and energy scarcity. In essence, thermodynamics is the science of energy, and energy is the driving force of our universe. Powering our world. Thermodynamics and power plants. Power plants are the backbone of modern society, providing us with the electricity we need for our homes and industries. These plants rely heavily on the principles of thermodynamics to generate power. Most power plants, whether fueled by coal, natural gas, or nuclear fission, operate on a similar principle. Heat is used to boil water, creating steam. This high-pressure steam then turns a turbine, a large rotating machine connected to a generator. The generator converts the mechanical energy of the spinning turbine into electrical energy, which is then distributed to our homes and businesses. Thermodynamics plays a critical role in optimizing the efficiency of power plants. Engineers use thermodynamic principles to design plants that maximize the amount of heat energy converted into electricity, minimizing waste and environmental impact. The more efficient the power plant, the less fuel it consumes, and the fewer emissions it releases into the atmosphere. Keeping cool and comfortable thermodynamics in our homes. Thermodynamics is not just about generating power on a large scale, it's also essential for our comfort and well-being at home. Refrigerators and air conditioners, two appliances we often take for granted, are prime examples of thermodynamics in action. Refrigerators work by transferring heat from a cold interior to a warmer exterior. They use a refrigerant, a fluid that can easily absorb and release heat. The refrigerant cycles through the refrigerator, absorbing heat from the inside and releasing it to the outside. This constant heat transfer keeps the interior of the refrigerator cold, preserving our food. Air conditioners operate on a similar principle, but instead of cooling a small enclosed space, they cool and dehumidify an entire room or building. They use a refrigerant to absorb heat from the indoor air and release it outdoors, creating a cooler and more comfortable indoor environment. Section 4. Powering planes, trains, and automobiles. Thermodynamics plays a crucial role in transportation, powering the vehicles that connect us to the world. From the internal combustion engines in our cars, to the jet engines propelling airplanes, understanding heat and its transformation is essential for designing efficient and powerful modes of transportation. Internal combustion engines, found in most cars, use the heat generated by burning fuel to power the vehicle. The fuel ignites inside a cylinder, pushing a piston that rotates a crankshaft. This rotational motion is then transferred to the wheels, propelling the car forward. Jet engines, on the other hand, use a continuous cycle of air intake, compression, combustion, and exhaust to generate thrust. The burning fuel heats the air, causing it to expand rapidly and exit the engine at high speed. This high-velocity exhaust creates a forward force that propels the aircraft. Section 5. Thermodynamics and a sustainable future. As we face global challenges such as climate change and resource depletion, thermodynamics offers a roadmap for a more sustainable future. By understanding how energy works, we can design cleaner and more efficient technologies that reduce our impact on the planet. Renewable energy sources such as solar, wind, and geothermal rely heavily on thermodynamics. Solar panels convert sunlight into electricity using photovoltaic cells. Wind turbines harness the kinetic energy of wind to generate power. Geothermal power plants tap into the Earth's internal heat to produce electricity. Thermodynamics also guides the development of energy storage solutions, such as batteries and fuel cells. These technologies store energy for later use, enabling us to rely more on intermittent renewable sources like solar and wind power. As Section 6. Conclusion. Thermodynamics. An invisible force shaping our world. Thermodynamics, often considered a complex and esoteric subject, is in reality an integral part of our daily lives. It's the invisible force that powers our homes, fuels our vehicles, and shapes our world. From the mundane to the extraordinary, thermodynamics is at play, influencing everything from the way we cook our food to the way we explore the cosmos. As we continue to push the boundaries of technology and grapple with global challenges, a deeper understanding of thermodynamics will be more critical than ever. It will be the key to unlocking new innovations, developing cleaner energy solutions, and creating a more sustainable future for all.